So we're going to do section 2. Yeah. Section 2 is verifying identity. So basically, in an honors class, I don't even think I should have done section 1 as a separate section, really. But what we're going to do is verifying, meaning you're going to have to prove that the left and the right side equal one another.
These are the ones that I hate.
Okay. Conserving my voice. Okay. So there are some strategies, like start with a more complicated side, use, reciprocal and so on, converting a denominator, okay? If no strategy presents itself, try converting the entire expression to one involving sines and cosines. But as you do more, you sort of, know, okay, when I see something like this, this is how I should start, okay? So let's start. These are like proofs in geometry where in the beginning they're uncomfortable and then you get better at them. I remember being in pre-calculus and being very, very confused when it came to these identities. It was like I was walking around in the dark. Yes, you do. Okay, so this one, we're going to start with the more complicated side, okay? That, I would say, of all of these, that's the most helpful here. The left side is clearly more complicated, okay? Now, tangent squared x plus 1, that's an identity. Secant squared x. The bottom, 1 minus sine squared, is just cosine squared x. What I do is I draw a line down the middle, like this. So now, yes, I'll talk about that later. Okay, so I have 1 over cosine squared x over cosine squared x. So this is 1 over cosine squared times 1 over cosine squared. So it's 1 over cosine to the 4x. 1 over cosine is secant, so this is secant to the 4x. Okay? Right. So you're done. Please. Okay, this one. So the left side now is simpler than the right side, so we're going to start with the right side. Okay, now, very, very clear. You have two fractions, common denominator. There is nothing else you can do, just a common denominator. So here, this is 1 minus cosine x, or I'll keep the order, 1 plus 1 minus. Now, the numerator is going to be sine x times 1 minus cosine x minus sine x 1 plus cosine x. Okay? Now, I'm going to do a couple things at the same time here. I'm going to distribute the top. We did that, in the last section. Sine x minus sine x cosine x minus sine x minus sine x cosine x. Now, the denominator is 1 minus cosine squared x.
How does it, I don't understand how it cancels.
It doesn't cancel. It's like 1 minus, yeah. Here, sine x and sine x cancel each other out. And what you have is negative sine x cosine x, negative sine x cosine x, negative 2 sine x cosine x, over What's 1 minus cosine squared x? Sine squared x. Equals. One sine cancels with one sine. Negative 2 cosine x over sine x equals negative 2 cotangent x, which is what we had here. Okay?
What about the minus cosine x? Wait, what? Oh, no.
Okay.
I get it.
So this one, okay, it does seem like they're both a little complicated. You do the one with a fraction. Okay, now, what you do when you have something like this, something minus something else, is multiply it with the plus version. So multiply this by secant x plus 1. And whatever you do to the bottom, you got to do to the top. So now, what I have is, on the bottom, secant x plus 1, secant x minus 1 is secant squared x minus 1. On the top, I'm going to distribute. So I'm going to get, you know what? No, I don't want to distribute just yet. Okay, now, what's secant squared x minus 1 in the identity? Tangent squared x. Remember, cosecant and cotangent are together. Sine and tangent, secant and tangent are together. Secant, tangent, cosecant, cotangent in the Pythagorean identity. So this is going to be tangent squared x. Now, I have a sine of x here and a tangent on the bottom. So why don't I change the tangent into a sine squared over cosine squared? Okay? So let me just rewrite that in a fashion that we can use. Sine x, secant x plus 1 times the reciprocal cosine squared x over sine squared x. So now one of the signs cancel. Okay? At this point, now let's distribute the cosine squared. When I do that, I have cosine squared x, secant x, plus cosine squared x, all over sine of x. Okay? What, not yet. What's secant? Right. Plus cosine squared x over sine x. Okay? Cosine and cosine go away. So I have right. Now, there's another trick. You can factor out a cosine here. And that'll give you, actually no, let's not do that. If you factor out a cosine, it won't do anything because you have 1 plus cosine.
Oh, it's not squared.
It's not squared.
Oh, right.
So another trick you can do when you have multiple terms in the numerator, but just one in the denominator, you can split them up like this. Cosine x over sine x plus cosine squared over sine. What's cosine squared? It's cosine x over sine x. Right? So what's this here? Cotangent x. What's this? Plus cotangent x, cosine x.
Hey, that's the same as the other side.
There you go.
Wow, that is
No way.
No.
These are kind of fun.
Told you.
There is nothing that compares to the satisfaction when you do one that's this long.
It's like a puzzle.
Yeah.
but what if it takes you like 2 hours?
It's like a math problem you need to add.
Then you're doing something wrong.
It's more of a puzzle. You can find the right answer to the problem.
Yeah. Okay. So let's do this one.
I'm assuming the test is no calculus.
Yeah. No, just right on the bottom. Okay. So here, what we can do is, let's factor out a cosine and a tangent x. So that's what we have, right? Is that right?
Oh boy.
Yeah.
Tan, anti.
What's secant squared minus tangent squared? 1. So this is 1, meaning I have cosine x times sine x over cosine x, sine x. Okay? Yeah.
I wouldn't know.
So this one too. Let's start with the left side. Factor out a cotangent x. What's cotangent squared x plus 1? Cosecant squared x. So this is cotangent x, cosecant squared x. Cotangent is cosine x over sine x times 1 over sine squared x. Okay? Cotangent is cosine over sine. Cosecant is 1 over sine. So now look at what we're going to do. Nothing. They're multiplied. I'm going to group those together. So I have cosine x times 1 over sine cubed x, cosine x times cosecant cubed x is what we need. Okay, so that's section 2. I do have, yeah,
For Wednesday.
yeah.